So we are in the middle of the development and execution life cycle of simple Spark application. It's not actually a simple one. We are actually trying to develop Spark application to get monthly product revenue. So far, we have gone through the problem statement, we understood the design, and also we made sure we set up a project using IDE, IntelliJ, and this project is the SBT project. And then we actually developed code till joining orders and order items and computing the revenue. So let me connect to my Windows machine here, and then we'll take it from there. Okay, now I'm connected to the Windows machine. It will take a bit of time to complete the login process. Once it is done, I just need to open the IntelliJ and we can take it from there. And also, meanwhile, I will be launching Ubuntu because as of now, we are using the Scala REPL to actually come up with the logic. And our project directory is nothing but MNTC users, Digadraju, idea projects, and then Spark demo. And then we can say SBT console and we can actually get into the Scala based REPL for this project. All Spark based as well as COM types of COM type safe config related dependencies will be available as part of this REPL. That being said, let me also open another session here. And as part of this session, we will get into this .scala history. Okay. If you actually open this .scala history, you can see the logic which we have developed yesterday. So using this, I can copy paste just to get up to the speed. So I will just say cat so that it will be easier for me to navigate through the history of commands which we have ran. I don't know why it has started these many sessions. Let me clean this up. Yeah. SBT console is still running. Okay. It got paused because I clicked on it. Now it is actually launching the SBT console. Now it launched the Scala REPL. You can also get the history by saying history and whatever number you want, you can actually pass that number and you should be able to see the history. If you want to get into the other list of commands in Scala REPL, you can just say :help and it will actually show you all different Scala REPL commands to actually interact with this interface a bit better. We will see some of these commands as we proceed further. For now, history is a bit relevant. However, if you say history, it will give the line number also. Instead of using history output, what I'll be doing is I'll be opening the .scala history file, which is part of our home directory. And from there, we can actually copy paste the code without making any changes to the code. And you can see the output of that Scala history, which is in my home directory. It's a hidden file. So if you just run ls-ltr, you might not be able to see that file. However, if you actually say ls-altr, you will be able to see that .scala history file. That being said, we started with importing this type safe config. So let's do that here. Okay, it is not copied. Let me do this. Let me copy from here to here. We just have to say enter, and then we can actually go to the other screen and we should be able to paste it. Once we created this input path, output path, props, month, etc., we can actually get into the code. However, when it comes to output path, I want to concatenate with something called monthly product revenue. Otherwise, what will happen? It will actually delete the entire directory as part of our validation logic. I haven't fixed the code yet in GIST. Today I will be doing that. However, I'm fixing it here. Once this is done, we can actually create the Spark configuration by copy pasting this one. However, we need to import both Spark conf and context. So let me select this and let me paste it here. And then we'll be creating configuration and context. So these fewer lines will actually take care of creating the configuration and context. As the context is being created, now let us actually get into the logic. I will not be validating today. We will be directly filtering the data of orders by checking against complete or closed and also for month of 2014 January. So that logic is there here. Also, once the filtering is done, we just need order ID and a hard-coded value, a constant value, because we don't need any other information than order ID from this orders. So here I need to define orders variable saying input path plus orders. Now let us copy paste that orders filtered logic, and now we have to take care of order items also. So let me copy this. So order items is the variable which have the path to order items. After that, we directly created a variable called revenue per order ID, and we joined both orders and order items. We have already filtered orders, and a new RDD is created with the name orders filtered. Using that, we actually joined with order items, and then we actually computed the revenue by using this logic. This is where we stopped yesterday. You can actually say revenue by product ID dot takeoff 10 dot for each println, and you should see the results here. Okay, so this revenue per product ID is nothing but a RDD, and each element in that RDD is of type tuple, and the data type of the elements in the tuple are nothing but integer and float. Now we have to go further, and we have to look up for the product name for this given product ID, and then we have to get the product name instead of printing the product ID. And also we need to sort the data in descending order by the product revenue for that month. That being said, okay, I'm not able to get the control of my Mac. Even then it is not giving me the control. I don't know how to get this. Okay, exit full screen. Yeah, now it should be fine. So this is the actual material which we are referring to. Okay, so if you actually get into the design, after joining the orders and order items, and after getting the product revenue for the given month, we need to read products from the local file system. So far we have assumed that orders and order items are in HDFS, and we directly are able to read it using sc.text file. However, when we actually deploy it in production, there can be a scenario where orders and order items might be in HDFS, and we might have to pass some external file, and then we have to process the data by joining this data from the external file with the other data in HDFS, and we might have to solve the problem. So we are trying to replicate the scenario on local file system on our Windows. Everything is local, but when we actually deploy it on the cluster, you will see the difference. However, with respect to the Spark running in local on the local machine or Windows PC using local mode, we'll be able to read local files either by using sc.text file or by using the Scala basic IO operations. So in this case, what we are supposed to do is we have to first read the products data into the collection. Once it is in collection, we can actually create RDD. And how to create that RDD, I will actually show you now. So first I'll be creating a variable called local path, and that local path is nothing but, in this case, almost the same location, mntc data retail underscore db. Okay, and then we will be reading the products data using scala.io.source. For that, we need to first import scala.io.source. Once that is done, we can actually create this variable called products using source.from file local path. Actually, in Scala REPL, you can autofill by just hitting tab by typing few characters with the names of the variables, and then you can actually give the remaining part for the product file name, which is nothing but products part -5 zeros. And then we can actually say get lines, which will create this collection called products. So now you can see that products is of type iterator of string, and it have all the records from the products. You can actually say products.take of 10 for each println. So in this case, this take is API on iterator. Earlier also we have used the take on RDD. So there is functions with the same names on RDDs as well as the primitive Scala collections. So take is one example where you will see in many collection data structures, and you can see the data here. Now again, this is a typical string where data is delimited by comma, and we are interested in this one, which is nothing but product name. So we want to join this data with our RDDs, which are generated after joining orders and order items, and then we want to get the product name instead of product ID as the final output. So the way you can do it is you can actually say sc.parallelize. So earlier we have used sc.text file to read the data from HDFS type of file system into the RDD. However, if you have a collection, now products is a collection. If you have a collection and if you want to convert into RDD, there is a API called parallelize, which is very important one. And then you can actually say products, which is of type iterator. So parallelize takes a list as input and it will convert into RDD. And if you run this, you can see that the output will be of type RDD and each element will be of type string, whereas products is iterator of string and products.toList will be list. So we are actually passing the list into parallelize and we are converting into RDD. However, if we try to iterate through the collection multiple times, it will become empty. It will be garbage collected. That's why you can see now it became empty iterator. To overcome that issue, we need to run this logic once again. And now products is of type iterator and each element is of type string. Now I'll be saying sc.parallelize. Let me assign it a variable val revenue per product. So this will be our variable name, and then sc.parallelize and then products.toList. So we are passing the collection of products into parallelize and converting into RDD. Once it is RDD, now we can actually apply whatever functionality we want or whatever API we want to get the desired functionality, and then we can actually join, aggregate, whatever you want to do, you can do that. Okay, so now we'll be joining this with the revenue per product ID, which is created earlier, which contain product ID and the revenue for that product. So here to join with the revenue per product ID, we have to convert the RDD of string into RDD of tuples, and the first element of the tuple should be product ID, and the second element of the tuple should be whatever information we need from that products dataset, which is nothing but product name. Once we have key value pair with respect to products, we can join with revenue per product ID, and we should be able to get whatever information we want. So in this case, I'm using map. So I'm representing each element in products as product itself. So it will actually process one product at a time. And then we want to generate a tuple. As part of that tuple, we have to split by comma, and the first element itself is product ID because it is primary key of our dataset and it is first element. And the second element second element in this tuple should be the product name. And the product name is nothing but third element in our data. So the first one is product ID, second one is product category ID, and third one is the product name. So the way you can actually get that is by saying split of comma and then 2. So now this revenue per product ID will be of type tuple. First element is of type integer, second element is of type string. So it's RDD of tuples. Okay, so to actually phrase it properly, revenue per product is of type RDD, and each element of that RDD is of type tuple, and the elements in the tuple are of type integer and string. Now I will be improvising on it after previewing the data. So let us first preview the data by saying revenue per product dot take of 10 dot for each println. You can see the data. Using this now, we can actually join with revenue per product ID by using join API. We just have to give the other dataset name, which is nothing but revenue per product ID, because it's already in the form of key value pairs. Okay. Once it is done, let us preview the data once again by using revenue per product. This contains the join results. Okay, I think it is not the case. Let me see where it went wrong. So revenue per product and then map, and then okay, there is a typo there. So I have identified that there is something wrong because it is supposed to have two elements and the second element is supposed to be tuple if join took place. But as we are seeing only two elements in each of these tuples without a nested tuple, I realized that something is wrong, and there is a bug in our code. Means there is a syntax error in our code. There is a E missing when we try to join. Actually, revenue by product ID, I guess. So the way we can actually get is by just hitting tab here after filling few characters, and the name is revenue by product ID. So I have to rerun this code once again with the correct RDD name as part of this join. Okay, now we can actually say revenue per product dot take of 10 dot for each println to preview the data. Okay, again there was an issue with respect to getting our products empty, so I have to rerun the logic once again. So let me copy paste this here. Now you see our revenue per product is of type tuple, means RDD of tuples. You can actually say revenue per product here to get the data type of this. It is of type RDD, and each element in this RDD is of type tuple, and the tuple have two elements. The first element is of type integer, second element is of type tuple once again, and the tuple again have two elements. The first element is of type string and second element is of type float. This string is coming from the products dataset, and this float is coming from the revenue by product ID dataset. Now as we got the product name and the revenue, we can discard the product ID now. We don't need product ID anymore. And to achieve that, what you can do is you can actually say val t equal to, as product name is string, we have to paste this and then put the string in double quotes. Now we have created a simple tuple and the name is t. Now we don't need the product ID. We can discard it. We only need the product name and the product revenue for that month, and it is already a tuple, and hence we just need to access these elements using t._2. Now we can improvise our code after joining like this: map and then rec and then implies and then rec_2. Rec_2 will give the tuple. However, our final requirement is we want to sort the data in descending order by revenue. As our revenue should be in descending order, instead of saying just rec_2 like this and create a RDD of tuple with product name as first element and revenue as second element, we have to swap it so that we can sort the data. So we have to say rec._2._2 to get the product revenue, and then rec._2._1 to get the product name. Once that is done, again sort by key expects data to be paid RDD, which means each element in the RDD have exactly two elements. As it has two elements, and as we got the product revenue as the first element as part of this map output, we can say sort by key false. If you say false, it will sort the data in descending order. If you don't say false, it will sort the data in ascending order by the first element in this output RDD of this map. Okay, so in this case, we want data to be sorted in descending order by product revenue, and hence we are saying sort by key of false. And then if you hit enter, now data will be sorted. You can actually preview the data by saying revenue per product dot take of 10 dot for each println and hit enter. Okay, once again the data is gone from the memory and it is not returning the results, but it works. So let me open the IntelliJ now and let us improvise the code. We already created the object by name get monthly product revenue, and we have added the logic to process the properties from application.properties so that we can actually run differently in different environments.